Okay, looking at what we have regarding the null space of a matrix, and for this particular part, we're going to be looking into homogeneous systems, and we will eventually be looking into non-homogeneous systems. And we have, with theorem 4.16, okay, we have for solutions of a homogeneous system, whereupon if A is an m by n matrix, then the set of all solutions of the homogeneous system of linear equations ax is equal to 0 is going to be a subspace of Rn called the null space of A, and is denoted by n of A. And now we have the dimension of the null space of A is what is referred to as the nullity of A. And now the null space of A is also called the solution space of the system A times x is equal to 0. And we have, for a given matrix A, the number of columns that exist will be equal to the rank of A plus the nullity of A. And for the dimension of the solution space, if A is an m by n matrix of rank R, so again, if A is an m by n matrix of rank R, then the dimension of the solution space of AX equals 0 is going to be n minus R. That is, n is equal to the rank of A plus the nullity of A. And just giving some samples here. Say if we have a matrix A and we're to determine the rank of A, the null space of A, as well as the dimension or the nullity of A, and we have A given as a 2 by 2 matrix where we have the top row at 3 and 6 and the bottom row we have with 1 and 2. And just looking at setting what we have for A, so A is going to have 2 columns, and looking at setting up what we have for A times x is equal to 0, and we have AX is equal to 0, and we're going to have for x, okay, x is equal to x of 1 and x of 2, and we're going to find out just what we're going to have for x of 1 and x of 2. So just putting what we have for AX equal to 0 in augmented matrix terms. So we got 3, 6, 0, 1, 2, 0, and the reduced row echelon form becomes 1, 2, 0 at the top and zeros at the bottom. And from the augmented matrix, there is only one non-zero row, so right away we can say that the rank of A is going to be at 1. And looking at what we have concerning the null space from the reduced row echelon form, so you got x of 1 plus 2x of 2 is equal to 0, and from this we're going to have the x of 1 is equal to negative 2 times x of 2. And now there is nothing whereupon we have x of 2 to be isolated, so x of 2 is regarded as a free variable, and we can set this equal to t. And since x of 1 is equal to negative 2 times x of 2, we have the x of 1 is equal to negative 2 times t. And for what we have for the solution of x, and just referencing again, have x equal to the vector matrix consisting of x of 1 and x of 2. And for our solution, again, we have x of 1 at negative 2t, x of 2 at t, and then factoring out we have t times the vector matrix consisting of negative 2 and 1. So the null space, okay, we're going to have s is equal to t times, again, have negative 2 and 1. And for what we have in terms of the dimension or the nullity of A, that's going to be the number of columns of A minus the rank of A. And again, A had 2 columns, and the rank of A again was at 1, so the dimension or the nullity of A is equal to 1. Okay, so this is what we have for A as a 2 by 2 matrix. And let's say if we expand the model a bit and let A be a 3 by 3 matrix, and looking at what we have here, now A is going to have 3 columns, and looking at what we have for the homogeneous system, so with A times x equal to 0, with x consisting of x of 1, x of 2, and x of 3, we have setting things up in terms of an augmented matrix. Okay, so you got the coefficients of what we have inside of A, and again we have the system where we have A times x is equal to 0, and we have zeros to the right. So we'll have a 3x4 augmented matrix, and putting what we have in terms of reduced row echelon form. So we have 1, 0, 5, 0, 0, 1, negative 1, 0, and we have zeros running across. So we got a consistent system. And from the top part, okay, we have the x of 1 plus 5x of 3 is equal to 0. And we have x of 1 equal to negative 5 times x of 3. And from what we have in the second row, x of 2 minus x of 3 is equal to 0. And we have x of 2 is equal to x of 3. So we have in this particular case, all right, so you have equations set up for x of 1 and x of 2 on the basis of the first two rows. But there's nothing for x of 3, so x of 3 is regarded as a free variable, and we will just set this equal to t. And for what we have defining x of 1 and x of 2 with respect to t, or in this case x of 3, we have x of 1 is equal to negative 5 times t, and x of 2 is equal to t. Now again, A has 3 columns. Now from the augmented matrix, from the reduced row echelon form, there were only 2 non-zero rows, so the rank of A becomes 2. Okay, and just going back for the null space, right, and providing the pathway here, so we have for the solution in x, where we have x of 1, x of 2, and x of 3, and we have, again, so we have x of 1 at negative 5t, and x of 2 and x of 3 both at t, and we have t times the vector matrix, where we have negative 5, 1, and 1. And so the null space, we can say that S is equal to what we have in parentheses, what we have in the solution for x itself. So you have t times, again, the vector matrix, negative 5, 1, and 1. And just looking at another case here, and before I do that, again, the dimension or the nullity of A, again, you had the number of columns, again, which was at 3. And the rank of A, again, was at 2. And the difference here, the dimension comes out to 1. Now, for our next case here, say we have A given as a 3x4 matrix, where we have 1, 3, negative 2, 4 for the top row, 0, 1, negative 1, and 2 for the middle row. And for the bottom row, we have negative 2, negative 6, 4, and negative 8. So A is going to have 4 columns. And looking at what we have for the homogeneous system, okay, so you have A times x is equal to 0, and we're going to have x consisting of x of 1, x of 2, x of 3, x of 4, and looking at establishing an augmented matrix. Okay, so we're going to add essentially to A an additional column consisting of zeros to correspond to AX is equal to 0. And taking what we have for the reduced row echelon form, so I have at the top row, I have 1, 0, 1, negative 2, 0, 0, 1, negative 1, 2, 0, for, again, for the middle row. And the bottom row, we have zeros across. And there are 2 non-zero rows once again, and thus we have the rank of A once again to be at 2. And from the top row, we have, from the setup, we have x of 1 plus x of 3 minus 2x of 4 is equal to 0. And so we're going to have expressing in terms of x of 1, that is going to be negative x of 3 plus 2 times x of 4. From what we have in the second row, okay, we have x of 2 minus x of 3 plus 2x of 4 is equal to 0. And isolating what we have for x of 2, we have x of 3 minus 2 times x of 4. Okay, and we have x of 3 and x of 4. These were not isolated, so those are free variables. So we have x of 4 is free, so we're going to set that equal to t. X of 3 again being free, and we will supply the variable s. And for what we have in the realm of the variables s and t, since x of 1 was established as being negative x of 3 plus 2x of 4, and branding x of 3 as s and x of 4 as t, x of 1 comes out to negative s plus 2t. And for x of 2, we have x of 3 minus 2x of 4, and again replacing x of 3 with s and x of 4 with t, we have x of 2 to come out to s minus 2t. So we have for x in the solution, okay, so we have again, we have x1 was negative s plus 2t, and then just x of 2 at s minus 2t, so we have separating, so you have like your negative s plus 2t, and for x of 2 we have 1s, and you have plus t times negative 2 in reference to negative 2t, and then for covering what we have for x of 3 and x of 4, so you have x of 3 is going to be 1s, and there's no t term involved, and for what we have with x of 4 at t, there is no s, and we have plus t times 1, so we have, again, so you have your x of 1, negative s plus 2t, x of 2 is s minus 2t, x of 3 is s, but 0t, so you have s only, and for x of 4, there's no s, only 1t. So you're going to have for the null space in this case, you're going to have s is equal to, and again, we have s times the vector matrix consisting of negative 1, 1, 1, 0, plus t times the vector matrix consisting of the column numbers 2, negative 2, 0, and 1. And the dimension or nullity of A, again, is going to be the difference between the number of columns of A, which we had to be at 4, and the rank of A, which we had just determined to be at 2, and 4 minus 2 equals 2.